There are 2023 distinct positive real numbers such that square root of the product of two expressions, an, is an integer for every n. Prove that a 2023 is greater than or equal to 3034. This is the problem 4 from 2023 International Mathematical Olympiad. 62% of the contestants solved the problem. This is relatively easy compared to the standard of competition. To solve the problem, we will use the mathematical induction and the AMGM inequality. Let us analyze this step by step. Assume P is the sum of x1 through xn, and Q is the sum of their reciprocals. The given equation can be expressed as an squared equals pq. When a1 is calculated, each expression contains only one term, and the terms are reciprocals of each other. Thus, their product is 1. Taking square root, a1 equals 1. Now, we consider an plus 1. Here, the additional term in the first expression is denoted as y, and its reciprocal is 1 over y, added to the second expression. The updated sums become p plus y and q plus 1 over y. We can multiply the two expressions by grid method. The terms are pq, p over y, qy, and 1. The product of two expressions is the sum of all terms in the grid. pq is equal to an squared. Now consider the two terms p over y and qy, both of which are positive. By the AMGM inequality, their arithmetic mean is greater than or equal to their geometric mean, with equality holds only when the two expressions are equal. On the right side, pq is equivalent to an squared, and we can cancel out y. Simplifying the inequality, p over y plus qy is greater than or equal to 2an. So the product two expressions, p plus y and q plus 1 over y, is greater than or equal to an squared plus 2an plus 1. This is the quadratic expression in terms of an, which can be factorized as an plus 1 squared. Taking square roots, we know an plus 1 is greater than or equal to an plus 1. We have already proved that a1 equals 1. By induction, we know a2 is at least a1 plus 1, so a2 is at least 2. By similar reasoning, we can say a3 is at least 3, a4 is at least 4, and so on. So a2023 is at least 2023. What we consider is that every number in the expressions is different. There may be conditions where the AMGM equality does not hold. When we consider a2, we have only two different numbers. Their sum is x plus y, and sum of their reciprocals is 1 over x plus 1 over y. Multiplying these two expressions, we get 1 plus x over y plus y over x plus 1. Since x and y are different numbers, x over y and y over x are not equal. In this condition, the inequality is strict, which means their arithmetic mean is greater than the geometric mean. This implies x over y plus y over x is greater than 2. a2 is greater than 2. an must be an integer. This means a2 is at least 3. The subsequent terms are at least 1 larger than our previous calculation. But we just want to a2023 to be greater than or equal to 3034. So a2023 is at least 2024 is still too lenient. To achieve a2023 is at least 3034, we can refine the lower bound by analyzing the progression from an to an plus 2 directly. From an to an plus 2, we add two distinct positive numbers y and z to the first expression, and their reciprocals 1 over y and 1 over z to the second expression. The additional terms formed by multiplying new numbers are p over z, y over z, qz, z over y, and 1. All numbers in the grid are positive. The product of the two expressions is the sum of all numbers in the grid. The original product is equivalent to an squared. Now let's focus on the bottom right 2 by 2 grid. Here, we consider the terms y over z and z over y. By the AMGM inequality, y over z plus z over y divided by 2 is greater than the square root of their product. The inequality is strict as y and z are distinct numbers. Simplifying the expression, y over z plus z over y is greater than 2. So the product of y plus z and 1 over y plus 1 over z is greater than 4. Now we consider the remaining terms. Factoring p, we get p times 1 over y plus 1 over z. Factoring q, we get q times y plus z. Using AMGM, we know the sum of the two expressions is greater than 2 times the square root of their products. Here, PQ is equal to AN squared. We have already calculated that the product of two brackets is greater than 4. Taking square roots and simplifying the expression, we get the sum of these four terms is greater than 4AN. Now, the expression AN squared plus 4AN plus 4 is a quadratic expression, and we can factorize as AN plus 2 squared. Taking square roots, AN plus 2 is greater than AN plus 2. Since AN plus 2 has to be an integer, the AN plus 2 is at least AN plus 3. This means A1 is 1. The alternate term, A3, is at least 4. The next alternate term, A5, is at least 7. The lower bound becomes an arithmetic series, and there are 1,012 odd numbers from 1 to 2,023. So, lower bound of A 2023 can be calculated by 1 plus 1,000, 11 times 3. Now we have A 2023 is at least 3,034.